So this is your chapter 1. 1 minute. Now what has happened to this one? Just a moment. Okay. Okay. So this is chapter 1, which is on matter. Okay. So one thing about a matter, matter is anything that has mass and occupies space. Okay. Now, when we say mass, what do you mean by mass? Can you tell me? What is the meaning of mass? And when we say occupying space, what does that mean? You guys can speak in the classroom, you guys can speak, and the rest of you guys can, answer through the chat. So I'm looking at your chat.
Like the volume of something?
Volume of something, okay.
The weight?
The weight, very good. The mass is, this meeting is being recorded. You guys can remove that.
It's the mass that occupies space.
Mass and occupies space, very good. So how do you measure the mass? What are the units for mass?
Like milligrams, kilogram.
Very good. So milligrams, grams, kilograms, right? Micrograms. So these are generally the weights in which, the units, these units signify whatever number you have. That number tells you like, okay, this is in context of taking the weight of an object. In other words, how much it weighs, what is the weight of it. Next is when it says it occupies space. When we say occupy space, this occupying space means we are meaning that what is the volume? Volume is two types. One is going to be for the liquids and the other is for the solids. Now, liquids is, what is the volume of the liquids? How do what kind of units do you use for measuring volume of liquids?
Like liter, milliliters.
Very good. Liters, milliliters, right? And then there is microliters, there is deciliters, right? So these. Now solids, what about the solids? Very good. Cubic centimeter, centimeter cube, right? So again, we will look into the units in a minute in the next chapter, but let's just, carry on with this, that anything, matter is anything. So chemistry is a study of matter. Okay, chemistry is that anything that everything in this universe. Now, I'm not just saying that the earth, but anything that you see in this universe is made up of matter. Okay, so our study of matter. So that's why it's a very interesting subject, because now you have all these variety of matters. Okay, but there are 3 states of matter. So this is point 1. Next is, what are the 3 states of matter? There are 3 types of matter. Actually, there are not 3 types. Let me just change it here. 5 types. 5 types of matter. Like 5 types of matter, or these are also called the states of matter. What are these called?
Like solid, liquid, gas.
Very good. So this is the solid one. Most commonly, we see solids, then we see liquids, and then we see gases. Right? Now, these are the commonly that we see on this earth. But there is also another state of matter lower than solid, which is called Bose, Einstein, condensate. Now, some pieces that I teach in the class are going to be above and beyond the book also, because in the end it's science. It's not just confined to one book. So I'll be explaining things, outside also. So anyway, so Bose and Einstein condensate. And then there is also another state of matter. Do you guys know? Another state of matter? Another state of matter. Yeah. It's called plasma. Okay. So here's the thing. You can bring these changes. You can bring the change from a solid to a liquid to a gas just by changing the temperature. Temperature. Now, what is temperature? What is temperature? Yeah, define temperature. You know, there's no right and wrong answer. It doesn't matter, you know, what, I mean, you just have to participate. It doesn't matter.
How fast the atoms are moving?
Very good. So temperature can be defined in the terms of like the kinetic energy, or how fast, or the motion. Okay, so the temperature, very good. It relates to the motion of particles, and everything is made up of particles, right? It has to be made, the small things that make up a particle. Okay, so motion of particles, and that is the kinetic energy in the particles. That's one thing. What else? Yeah. Very good. So that is at what temperature the change of state happens. Very good. So boiling point, freezing point, melting point, you know, these are when the change of state occurs. So temperature is how hot a substance, you know, degree of hotness and coldness. So hotness and coldness, lack of heat. So how much of the heat is there, and the lack of heat. Okay, so this is the, so there's less heat, obviously you will feel cold. If there's a lot of heat, you're going to feel hot, right? So that's the thing. Now, you can make a change. So these three states of matter, let's look at first of all, the solids. Solids, what are the properties of solids? What do you know about solids? Or what examples do you have of solids?
An example would be ice.
Ice, very good. Example of solid is ice. Okay. So what is it made up of? Okay. In solids, the particles are very close together. Okay. Now the solids can be made up of atoms or molecules. We'll look into this in a minute, but there is a very strong intermolecular, or like very strong attractive forces, you can say that, in between the particles. So strong attraction in the particles, strong attraction, okay, in the particles. So that's the thing with the solids. So solids will have what? A definite shape, right? Definite shape, and all the solids will have a definite volume. The amount of space they occupy, all of them will have a definite volume, okay? So that's the deal with the solids. Let's look at the liquids. What are liquids? Example, just give an example first of all.
Water.
Just plain water, very good. Just plain water, okay? So here, the particles are arranged in a more mobile fashion, or in other words, there is lesser attraction. The attraction in the particle is still there, but it is lesser attraction in the particles, lesser attraction in between the particles, okay? So that's one thing. Next is their shape. What about the shape? Very good. So they take the shape of the container. Take the shape of container. So wherever you put them, in a jug, in a beaker, in a flask, or you can put them in a, you know, in a bottle, whatever. They take the shape of that. But what about their volume? Definite. That is what, see that in the that is why you see, you know, you go to the grocery stores, gallons of milk, right? You know, those pints, and so the volumes are very definite, and based on the amount of mass or the matter is there, you get charged. So volume is again definite in this case. Okay. Next is the gases. What's the deal with the gases? Example of gases?
Water vapor.
Water vapors. So water vapors are in nature. Where do you find water vapors?
Like with fog or mist.
Very good. Fog, mist, those things. Fog, mist, and even like steam, you know, so steam is also like wet water vapors, like, so fog, steam, mist. So you can feel it, but it's you know, it's in the gaseous form. Okay, so in the gaseous form, the particles are very, very far away, very far away. So which means that hardly any, so no attraction. Oh. Sorry about that. Okay, we'll go back. Okay, sorry about that. I don't. Okay, so no attraction in the particles. No attraction in between these particles. So which means that, what about the shape? Again, and the volume.
Indefinite volume.
Yeah. So the shape also, they are going to take the shape of container. Okay, so that container could be a balloon. The container could be a cylinder. The container could be like a tube, you know, so gases can be put into those, you know, any container. So container is like a very generalized thing. Okay, so that's the deal with the gases. Now comes the volume of these gases. Now, here's the thing, the nature of the gases, because gases could be compressed and gases can be expanded. Compressed and the gases can be expanded. And so because of that, their volume remains indefinite. So yeah, it's a matter, it will still have a definite, some amount of volume it will still have, depending upon what is the mass. But the thing is, you can squish the gases. So it's a small volume, gases can be expanded, large volume. So that's the situation with these guys. Okay, so now that is a very general stuff between the solid, liquid, and gases. Now you can bring these transformations between the solid, liquids, and gases. So let's look at these transformation. You can change a solid to a liquid. Let me put this here, number 3. You can change a solid to a liquid, and you can change a liquid to a gas, solid to a gas, gas to a liquid, and so forth. So you can bring these transformations. How? Just by changing the temperatures. So solid can be made into a liquid, liquid can be made into a gas, and gas can be made into a solid. And on the other hand, the liquid can be made into a solid, solid can be made into a gas, and what is the other one? The gas can be made into a liquid just by changing the temperature. So here, T stands for temperature. Now, something about chemistry. We use a lot of short forms. So instead of writing this TEMPERATURE, like a huge big word, we just write T. So we use a lot of symbols in chemistry, okay? Now, how can you make, now let's do some simple ones. Just imagine solid to be ice, liquid to be water, that is in the liquid state, and gas is like a vaporized water, like steam or mist. Okay, so those things, you have the picture in mind. Now, you tell me, how can you convert a liquid water to solid? What can you do? Freezing, very good. So this is when you freeze it. So at what temperature? Does it at a high temperature or a low temperature? Or for water, if you know, what is that? What is it called? It is called freezing point. Okay. And what is the freezing point of water?
Low temperature?
40 Celsius.
Celsius is 0 degrees Celsius. Okay. 0 degrees Celsius, the water. So yeah, this is good, guys. So see, when you communicate through the chat, I can see you, even if you can't speak, it's okay. So you're, you know, I can see your classroom, you know, response and participation. So this is good. Okay. So temperature, when the temperature goes down, you need to reduce the temperature. So keep this in mind. Everything in chemistry or in generally science, and especially chemistry, is in reference. So for us, the reference is with respect to 25 degrees Celsius. That is the room temperature. So when we say higher temperature, that is in respect to the room temperature, and that's 25 degrees Celsius. Okay, so so room temperature, RT, R dot T. So that's what it means. Okay, now we have, I'm recording, right? Yeah, okay. Okay, now we have going from a solid, going from a solid to a liquid state. What is it called? Solid to
Melting point.
melting. Very good. So this is melting. And at what temperature will ice melt?
Would that be room temperature?
Yeah. So anything that is above 0 degree, it begins to melt, you know, and so by room temperature, generally we see the ice melting. So that anyways, that temperature is the at which the ice melts or any other substance melting point. And that happens when the temperature is increased from the freezing point. So you see those two changes. You see this change right here, going from liquid to a solid state, and the opposite of that. So you see this change in temperature. One is temperature down, the other is temperature is up. So that's, you know, that's what it is. Okay, so basically in the end here, water can be changed into ice and ice can be converted into water. So these are physical change. This process, this is physical changes, because we are only changing the appearance, how things look, but we are not changing the actual, like what are the particles made up of, or the arrangement of particles, like the chemical arrangement. But we are just changing them, making them from, you know, rigid solid to more mobile liquid. Just that we are changing. So by changing temperature. Okay, next is liquid to gas, quickly.
Boiling point.
Boiling, very good, excellent. So when you boil things, yes, things begin to heat up, but at a certain temperature only, you will see that the liquid converts to vapors. What about the gas converting to liquid?
Condensation.
Condensation, very good. So where do you see condensation?
In the air?
Water bottles?
Water bottles, yeah. So if the water bottle is very cold, right? So water bottle is very cold, and what happens is that water is very cold, then the outside air is hot. So outside air is what? Water vapors, right? So these water vapors, when they strike the surface of a cold bottle, then there is a transformation happens from a gaseous state to a liquid state. And that happens when the temperature goes down. That is cold, when it only strikes a cold surface, okay? So that's one thing. So higher temperature is boiling, opposite of that is condensation. So these processes. Next is now going from a solid to a gas state. Solid to a gas state.
Solidification.
So this in the lab, sublimation. So we have iodine in the lab, and you will see how iodine, which is in a solid state, converts to a vaporized state, and the vapors are purple colored. Okay. All right. So, okay. So that sublimation happens when you increase the temperature. So iodine. Iodine is very beautiful solid, and it is crystalline solid, and it is it's a crystalline solid, and it's it's purple colored and very shiny, beautiful crystals. It's amazing, but it's poisonous. So anything that is toxic, it's just, you know, you have to be careful. So anyways, so that's when you take that solid iodine and you put it in a hot water, immediately it vaporizes, you know. So that's one thing. Besides that, you know, dry ice, you've seen dry ice fuming. Have you seen dry ice? That is basically carbon dioxide. Yeah, carbon dioxide has been squished and made it into like solid, you know. So dry ice is basically at room temperature, it's converting to gaseous carbon dioxide. So that's when the temperature increases. Okay, next is solid to gas to a solid. What is that? solidification. Very good. Solidification. Okay, so solidification happens when it's very cold, like let's say, let us say, like in very cold environments, the outside air is extremely cold, and you see the thing,
Record, please.
you see this on the windows of your rooms. You will see the ice, you know, like taking those beautiful shapes of, or icicles forming, you know, so that happens at the low temperature. So here you see temperature increases and temperature decreases. That's all. And all you see is basically the conversion from a solid to liquid to a gas state of not just water, but anything you can convert that. Now, here's another thing when we talk about the Bose-Einstein condensation plasma. So what happens is, if you have a solid, let me just put another color here. If you have a solid, okay, you have a solid and you take the solid and you freeze it even further. You know it that, you know, liquids can be frozen to solid, right? And what happens if you keep freezing the solid also? That's where Bose-Einstein condensate forms. And this condensate is basically, it's very interesting. This is, you know, the particles begin to lose their identity. And it's a very, it's like, you can just think of it like it forms a slush, like, you know, like that type of liquids. So they begin to lose their identity. So that happens at like very low temperature, like near absolute zero. Absolute zero. And what is absolute zero? Absolute zero is 0 degree Kelvin, 0 Kelvin. Okay, 0 Kelvin. And we'll talk about these Kelvin and Celsius in a minute. So this is one piece. So that is, commonly we don't see it, because obviously you need to bring the temperature that much down, and that can only happen in the labs. And we have not been able to actually bring the temperature down to absolute zero for, you know, like it's, but that's what I'm saying, near. Now that's one piece. Next is, if you take a gas, right, and you convert, so liquid can be converted to gas, which is fine. But the gas, if you heat, so this here, you bring the temperature down, and here, if you the temperature, then it becomes plasma. Now, what is plasma? You guys know plasma? Okay, plasma is like fire. It looks like fire. Looks like fire. But plasma is, you know, like the sun. The sun is all plasma. So that state of matter. So when the gaseous are super heated at a very high, like thousands and thousands and thousands of degrees Celsius. And so basically this is the ionized gases. So plasma is basically ionized gases. So we will see what what the ionized gases, ionize mean. So for now, you know, it's an introductory chapter. So keep on to this. So this is what, this is called a transformation, when you can change the states just simply changing the temperature. Okay, now another thing that is very important is the physical and the chemical properties of the substances. What are the physical properties and what are the chemical properties? So physical properties and chemical properties. Physical properties are how a substance looks, basically, you know, in the initially it's that, like how does it, so how it appeals to the senses. Okay, like for example, how a substance looks, right? You can tell a difference between water and a water bottle, right? You can tell, like water is different. Water bottle is different. Both of them are not the same thing. So you can tell, oh, there are two things here. Now, not just two things. Here you have this little piece of like this solid thing, and this is also solid and different color and is hard. And you can tell this is plastic and not something else. So it's kind of like how a thing looks, how a substance feels to touch, you know, feels like when you touch it. Does it soft? Is it hard? It is like gooey? Is it like, you know, those things? Then what is the color of the substance? That's the look part. Then how does a substance taste? Although we don't, you know, recommend people tasting, but in the past, people, you know, scientists were identifying substances based on their taste. Okay. Then just change this taste, and then comes the so look, taste, touch, smell.
Sound.
Yeah, and sound, yeah. So how does it like, does it have a crinkly sound? Does it have a soft sound? Does it have a metallic sound? When it falls, does it falls with a thud sound, like all those sounds? So these are basically our, we identify a substance based on our senses. Next thing, we also identify a substance by looking at, like you talked about, like at what temperature does it boil? So at that temperature, that boiling point, the melting point, you see this? Let me put this in another color. The freezing point is going to be the change of state. Melting point, the change of state. Boiling point, the change of state. Okay, so all these change of states, every substance has a very unique boiling point. At that temperature, it changes from a liquid to a gaseous state. Okay, freezing point at a very peculiar, at a very specific temperature. Every substance has a very specific, their freezing point when they go from a liquid to a solid state. And melting point, again, every substance, it's very characteristic of that substance that they're going to convert from a solid to a liquid state. Okay, so these are one thing. Next, a substance, what is the solubility of the substance? Will it be soluble in water or not? Will it dissolve in oil or not? You see that? So solubility in different types of mediums. Okay, so solubility is also a very important characteristic. Besides that, there is also a thing called density. Is the substance floating on water, or is it going to sink in water? Is it heavier than water or lighter than water? So density is very important. So like you see, I'm saying water because water is used as a reference. So density of water is generally 1.00 grams per milliliter. So this is the units. This grams per milliliter is a unit which tells you this is the density of a liquid. Okay. Similarly, the density of ice, because ice cubes, So again, that can also be, this is going to be less than 1.0 grams per centimeter cube. Okay. All right, guys. So density of ice is less than water. So when it's less than water, that means the ice is going to float on water. Okay, that's why. So just keep this in mind that this piece right here shows the unit for the density. That is in that context. And then these numbers are basically, you see everything is relative. So you start with one thing and then you measure other things in relation to that. So water is like mostly, that's tested. Besides that, we look at the other type of qualities also, like malleability. Now, what is malleability? What is malleable? Malleability, M-A-L-L-E-A-B-I-L-I-T-Y, is can you beat the substance into thin sheets? Okay, so when you can make, let's say for example, aluminum foil, right? Aluminum foil, can you beat it into thin sheets? Silver foils, right? Aluminum can be made into thin sheets. Generally metals, silver can be made into thin sheets. Okay, and I'm going to just remove this here so we get the chemicals later. Okay, so that's malleability. We can make them into thin sheets. Next comes ductility. Now, what is ductility? Ductility is, can you make it into what? Can you make the substance into?
Metallic sounds. Oh, sorry, no. Wires or coppers?
Wires, very good. So ductility. Ductility is, can you stretch them? In other words, can you stretch them into wires? So what is the tensile strength? So not everything can be stretched into wires. So only certain type of substances. So the strength of a substance, or strength, and also the, stretch into wires. Okay, stretch them into wires. So that's so here, for example, copper. Copper can be made into wires. Like iron, you know, iron rods, we see them, right? Now, I'm going to also put here COPPER, like the symbols. So this is the symbol for copper. This is the symbol for iron, okay? Aluminum, the silver is AL, and the symbol for silver is AG. And we'll talk about the symbols in a minute. Okay, so that's one thing. Besides that, you know, what else was there? Malleability, ductility, yeah, conductivity. Now, conductivity is, can a substance conduct heat? Can a substance conduct like light? Conductivity. Can a like glasses can conduct light? So generally, you know, like sound also. So heat, generally conductivity is heat and electricity. So that is why copper wires can conduct electricity. You see that? So that heat, so these are the general, and then there are many more, you know, but we are going to just stick to these common ones right here. These are called the physical properties of the substance. So you define a substance like gold property. So gold is going to shine, right? Silver is going to shine, aluminum is going to shine, copper is going to shine, but iron doesn't shine, you know, so that's a property. So you can clearly look at it. Like, for example, like some gas, like carbon dioxide gas, right? Or carbon monoxide gas. Now, those are poisonous gases. So you can like faint and you can fall down and you can like, it can even kill people. So again, that's toxicity is a property, okay? So those are the physical properties. Next comes the chemical properties. So let's look at the chemical properties. Now, chemically is, how do they react? Are they reacting like readily or not? So chemical properties are, or will they even react with each other? Sometimes they don't. It's not all the time that you mix things are going to react. No, reaction is whenever new substance is produced. So in chemical properties, we will see that how does a substance, you know, when it reacts, so what kind of new substance is it producing? So new substance. Now the word substance is common word, like it's commonly, you know, common thing about the matter. So when we are just saying it about, like, it can be solid, it can be liquid, it could be, so it's a very generalized term. So when a new substance is formed, that is a chemical reaction. Now, what kind of new substance will be formed? Well, that new substance, can it even form a new substance? That's the thing. Will it even react? So that's the chemical property. So if it is reacting, then is it producing a gas? And how do you see a gas? So you're going to do this all in the labs. You're going to see that in a chemical reaction, there is fizzing, there is bubbling, there is, you know, fumes coming out, okay? The fumes. So you will do these labs and you will see them. So there are fumes and you will see them. Besides that, can it form a solid? And you will see this also. So can it, when we say it is forming a solid, that means precipitate. Okay, will it form a precipitate or not? So that means it is insoluble in water. It does not dissolve in water. Insoluble in water. Okay, now water, and water, the formula for water is H2O. Okay, then besides that, some of them also release heat. Now heat, sometimes if they absorb heat, some of the reactions absorb heat, some of the reactions release heat. So these are all chemical properties. Okay, so you will see that. Now that's the thing with, now there is a chemical change and a physical change. Then comes this concept of chemical change and a physical change. Chemical change. When is a chemical change occurs? So chemical change occurs whenever a new substance is formed. Okay, so how do you know a chemical change occurs? When you see color change, not all the time, but yeah, most of the time. So there is a color change. Okay, there is a change of state. You will see a gas, you will see a solid forming, and you can also see another liquid forming. So all these, you know, these are also formed. Okay, and evolution of heat, or, you know, either you're going to feel cold, the reaction feels cold, or the reaction feels hot. So when the reaction is feeling cold, that means when you touch the test tube, right? There's a test tube, you touch the test tube, and that means it's absorbing heat. And if it feels cold, that means it's absorbing heat. So when your hand feels cold, so that means the reaction is taking the heat from your hand. But if your hand feels hot, when you touch the reaction vessel, and could be a test tube, that means it is giving away heat. That is why your hand is feeling hot. Okay, so that's the thing with the chemical change, and we will study about chemical change more. But let's focus now on the physical change. You're going to do this in the lab again. So 4, 3, 4, 5. Okay, here is your physical change. Physical change. Physical changes are temporary changes. This chemical change is a permanent change. You cannot recover the original, you know, the two things that were mixing together. You cannot get them back. So that is why you get a new substance is formed, new substances. So you cannot recover original components, cannot be recovered. Original components cannot be recovered. Okay, this means that, you know, just completely destroyed. You cannot get them back. How does a chemical change look like? Let me just put it here. How does it look like? Now, here's the thing. Look at this here. Hydrogen is a gas. So this is how you show. This means a hydrogen. So this is the language of chemistry. Hydrogen gas. When hydrogen gas reacts with oxygen gas, and this is again, G stands for gas. So this is oxygen. This is the name of the gas, oxygen gas. When these two are mixed together, they form H2O, which is a liquid, and that is water. Okay, and then there is a balancing also. So 2 and 2. So when two particles, or in other words, two molecules. So two molecules are particles. When two molecules of hydrogen react with one molecule of oxygen, and again, so these are the molecules, means the smallest particles. They produce two molecules of water. And so this is again, these are the particles, two molecules of water. So that is a chemical reaction. Now, how do you know? So here's interesting thing. Hydrogen, when you bring, it's very flammable. These two guys actually, hydrogen and oxygen, both of them are flammable, means they are going to catch fire. Okay, they catch fire. So oxygen is going to explode with fire whenever there's fire. And hydrogen also explodes. So it burns with a pop sound. But water, on the other hand, is inflammable. So you see, whenever a new substance is formed, it will always have new properties. Okay, so when we say a new substance is formed, that means new substance will have new properties, not the same as the initial, you know, components of what it was made up of. So here you have the water forming, which is used in dousing the fire. So this is the story with the chemical reactions. Now let's look at the physical change. Physical change is, physical change is temporary change. You can recover the initial components. So physical change is temporary, and your initial components can be recovered. Nothing changes. So for example, here, you take salt, and you're going to do this in the lab, or this has already been done for you actually. You take salt and mix it in water, and then what happens? This salt and water, they form a solution, and it appears that the salt is vanished. But like I said, this is just a temporary change. You can recover the salt back by the process of evaporation. So you all know that if you take the solution, you put it on a container, a dish, and you heat it, the water will evaporate and the salt is left behind. So you will do this in the lab. So in this case, no new substance is formed anytime, you know, no new substance. So I'm going to just leave it like that. Substance is formed. Okay. All right. Now let's look at the last part, which is about the pure substances and mixtures. Now, what are pure substances? Pure substances are only made up of one type of particles. Pure substances are made up of only one type of particles. So here's an example. Example is, for example, aluminum foil. You guys have seen aluminum foil. So this aluminum foil is made up of only one type of particles which have the properties of aluminum. So you guys kind of have an idea of what are the properties of aluminum foil. So here is your aluminum foil that, you know, makes that crinkly sound, shiny, you know, has some strength. It has been beaten up into thin sheets. So those are the properties of aluminum foil. Aluminum, if you take aluminum, you take scissors and you start breaking it up into small and small and small and small and small parts. So what happens is that the absolute last part that is left, that still retains the property of the aluminum foil. That is called atoms. So the smallest particle of any substance is the smallest particle, smallest particles, actually pure substances can be, wait one second, I have to change this, made up of only one type of particles. I'll put this here in a minute. Okay, so that's the aluminum. Next is, let's look at, for example, salt. Now the salt is made up of like sodium and it is made up of chlorine. So chemically, it is made up of two particles. So here, this is only one particle, one type of particle. Okay, let me just hold on to this because I need to make this. Pure substances are actually two types. One is the elements, okay, elements, and the other is called a compound. Now, what is an element? Element is made up of atoms. So elements, the smallest particles, and these are called atoms. So if you take, like I said, aluminum foil, if you take the aluminum foil and you start taking a scissor and you cut it into small part, the last part that cannot be further, you know, broken or divided, that would be atom. And it will still retain its physical and chemical properties of aluminum foil. Next, compound. Here, the smallest particle is called the molecule. And this is the molecule. Okay. For example, you have water. Now, what is water made up of? Water is made up of two atoms of hydrogen and one atom of oxygen. Now these atoms, these are chemically combined. Okay. So when they are chemically combined, that means they have bonding, they are bonded. So chemically combined. So it's not just, you're not just mixing. So they are chemically combined. How? Here is your oxygen, here is hydrogen, this is another hydrogen, this is going to be at an angle, and that's going to be a particular shape. These are the lone pairs. So don't worry about all this if you don't understand, like all the other lone pairs and all that. These are called the lone pairs. But these two atoms of hydrogen are going to connect with oxygen, and that connection is through a bond. So this is a bond, and this is also a bond. So this bond is like stitched together. They can be broken easily. Okay, so that's chemically combined. So whenever a chemical reaction happens, some kind of, remember that, some kind of rearrangement happens. Rearranged. So particles, particles are rearranged in a chemical reaction. Okay, in a chemical change. In reactions. Okay, I'll save all this as PDF so you will have it. Okay, so this is the deal with the pure substances. Next comes the mixture, pure substance. Next comes the mixtures. Now there's a difference. Mixtures are mixtures, as the name says, mixtures. Mixed when two things are mixed together, but it's not chemically they are mixed together. So that's just a physical. So mixtures are just a physical process of mixing things. You're not producing, it may look like you produced a new substance, but you can recover it back. So it is just a physical change when you mix two things together. Okay, but if the particles are not breaking up, remember here in chemical reactions, there is always going to be, the old bonds are going to break. So here, bonds break. Here, bonds break. Of which one? Hydrogen and hydrogen we talked about here. This is the hydrogen and hydrogen bond break. And here oxygen and oxygen double bond actually break. And then they rearrange. And how do they rearrange? They rearrange to form water. They only need one oxygen and two hydrogens. Like that. And that's always at an angle. So this rearrangement, so all that requires a lot of energy. But when you do mixtures, you're not creating that rearrangement. You're not breaking, no bonds are being broken here. No bonds break. So mixtures, again, two types. One is a homogeneous mixture. Homogeneous is they look the same. Homogeneous, and the other is a heterogeneous. Now, homogeneous means they are the same. They look the same. Here you can, here you can identify the components. Identify the components in the heterogeneous mixture. But in the homogeneous, you don't. For example, sugar, white sugar, and salt. You can do this at home. You mix salt and sugar. They all look one. But in this case, you can take wood and you can take, let's say, wood and you can put sand. So sand you can see separately and wood you can see separately. So that's a heterogeneous mixture. Okay, so these are the very basics, of this chapter. So we just covered all of it. Let's see what else is left. So pure mixtures and elements and compounds. We covered your substances. Okay. Discovery and abundance. Now, name of the chemicals. Now, okay, these are the two things. Let's see. All right. Just give me 1 minute. Give me 1 minute here. I'm trying to. So, where is the. Okay, so this is one piece. This is what we'll do in a minute. There's something else I want to try. Just give me Okay, so we have the okay, that's one. Periodic table, and then we have okay. All right, so you guys have right here. Okay, and you guys have so okay, now you guys can see. Okay, so I just want to make sure. Can someone tell me from the Zoom, you guys can see the table?
Yes.
Yes.
Okay, good.
Yes.
All right.
Yes.
Okay, so here's the thing. Now, next we are looking at the elements. Okay, so now in this universe, on this earth especially, what we see is the substance. Everything is made up of matter, right? And that matter, we looked at it basically two types, major types: elements and compounds. Elements are pure, very pure substances. Pure substances means that they are made up of only one type of particle. So what you see in the periodic table, like this one we talked about in your handouts, right? And generally you see this type of periodic table. This is the arrangement of elements as they are found in nature. So this information you see is the property of, is information about the elements. And element is made up of only one type of particles, and the name, and those particles are called atoms. So this periodic table is showing the arrangement of atoms in an order. Okay. But before we go that, let's just look at some of the very interesting things in nature about these elements and all the interesting things. So here I'm going to show you here. For example, let's look at copper. Copper. Okay, so what are the properties of copper? What do you see here?
Metallic and shiny.
Metallic, shiny, yes. What else?
Reddish orange.
Reddish orange color, very good. Anything else? So that is like, it's a good conductor of electricity. So you see right here, these, I can't zoom it. Yeah, like see, these are see the density, 8.96 grams per centimeter cube. This means that it is heavier than water. So if you put it in the water bottle, the copper wires are going to sink. Look at the melting point. Look at the boiling, I mean, look at the boiling point. It's like thousands, 2,562. So this is the physical property of this element called copper. Look at this sign here, Cu. So remember in chemistry, we use these, symbols, and we will look into these symbols in a minute. But here you have there's information about the atomic weight. Atomic weight, when we say atomic weight, that is the weight of the atom. And that atom, remember, if you take copper, you take scissors and you break the copper into small parts. The absolute last part, which cannot further be subdivided by, common means or normal means. So that last part, that still looks like copper. That last atom, the weight of that atom is 63.54, atomic mass units. And then, so that's the information about the atom or the particle of which copper is made up of. Now, this is the physical properties. But when you mix copper with some other substances, then all these are called copper salts. They are blue in color. Copper salts are blue in color. Now, there is a lake, I think it's up north, Oregon, I think somewhere, I don't know if you guys are aware of it, but there's a lake in up north, which is very blue color, and people go there to see that lake, So it's that blue color of the lake is because it has copper deposits, copper salts. So whenever copper mixes in water, it will form, the blue color solution. Anyway, so here is this copper, you know, pennies we use and so forth. So copper wires, they conduct electricity. So that's the deal with copper. Next is, let's look at, one second, how do I go back? Okay, let's look at, commonly you guys know gold. Everybody knows gold, right? Gold, shiny, you know, solid, and but at the same time, gold is also, look at the density of gold. It's heavy. 19.3, it's pretty heavy. So it's going to, but look at the boiling point and the melting point, very high, right? Next is gold will not react with anything. So that is why gold can be used, you know, for certain specific things, but, you know, jewelry is one thing, but gold plated chip mounts and, you know, other things. So, so the gold, there's purple gold and, you know, those things. So that's the thing with gold, but that's the properties of gold. Now let's look at, for example, what else? Let's look at mercury. Now mercury is also like shiny, and it also gives the, but at the same time it's liquid, it's not solid. So all the elements that you see in the periodic table, only two of them are liquid. One is mercury, the other is bromine, and you will see bromine in the lab. But here's the thing, whenever the boiling point is negative 38.83, that means, you know, this is always in reference to the room temperature. So that means it's liquid at room temperature. Melt means that melting is like, first it's already existing as a liquid. It has to be converted to solid, only then it will melt. So that's like at a very low temperature. But anyways, it's pretty dense, and you've seen mercury in the thermometers. Okay. Now here's an interesting thing. The same mercury, this is very toxic. You see the symbol of mercury Hg, and these symbols also are coming from somewhere, but 80 is the atomic number. Okay. And so the mercury, which is very toxic, right? I mean, it can kill you or it can cause some neurological harm, but the same mercury, when you mix it with, you know, where is that going? When you mix it with, I haven't shown here, dental, yeah. So when it mix it with something else, like mercury and zinc, then you have this dental fillings. And dental fillings, you know, it's harmless. So that's an amalgam. So you see, that is what the beauty of chemistry is. Yeah, fine. You know, you see, and we're going to visit this. I'm going to take you again and again to this thing, looking at all these elements, but let's just focus on this now. So all these elements that you find in nature, we have arranged them in an order. Now, what is that order? Look at that. You see this hydrogen, the weight of the hydrogen atom. Actually, hydrogen, so we'll discuss this more. They are made up of like protons, neutrons, and electrons. So we'll do this tomorrow. But right now, what is important is that focus on the symbols. Okay, hydrogen is H, lithium is Li, sodium is Na, potassium is K, rubidium is Rb, cesium is Cs. Okay, so for this first chapter, symbols are important. Just get yourself familiarity with these and these symbols now. And then at some point, you also have to remember their, you know, like their arrangement in the periodic table. Where are they arranged or how are they arranged? So for now, it's important you just get the symbols, names of the symbols. Okay. Now I have a video already on the symbols, but the video is, one second, you guys have it. So let's just put this here. Now you guys see I'm writing something. Can you guys see on the Zoom? Because sometimes it doesn't show.
Yes.
Okay, good. So here we're going to memorize I'm just letting you know this up front, memorize the symbols, because that is the language of chemistry, symbols of elements. Now, I have a video made on how to memorize them, but that's just one style, right? Many people can, you know, like learn it by, you know, just rote memorization. Some people like to create some kind of like, what is it called? Like mnemonic or something. I don't know, some kind of, they have their own ways of doing it. But anyways, just keep this in mind that these symbols have come out, number one, after the names of some important persons, like Einstein, Einsteiniums. Okay, so the names of the like scientist, Rutherford, so Rutherfordium. Okay, then you have like, for example, Seaborgium, after Seaborg. So let me put this out, Seaborgium, like, let's just get this, like, Bohrium, BH, like Niels Bohr. Okay, so if you know a little bit of the history, or, you know, you can just kind of get it. Like, one second, let's see what else is there. Livermore, no, where did I put this here? Bohrium, and I'm just trying to see the names of the few people more who are Einsteinium. Yeah, Einsteinium is ES. Okay, so these are like the common, and Nobelium, like after the Nobel Peace Prize, you know, Nobelium. So this is the names of the scientists. Then there are the names of the places. Okay, so that's another easy way of remembering is, like, for example, Californium, right? California. Berkelium. So Californium is, one second, CF, Californium, right? Berkelium is BK, okay? Like Francium, after France, right? And then some of the other ones are like Indium, like after India. So like that. Okay, next is the names of like some celestial objects. Okay, so names of like some planetary, like objects, like for example, thorium, TH, like cerium, you know, like, or some mythology, you can say, like coming from some mythology. So those names. And there is no hard and fast rule why it is TH and why it is something, you know, those things, there's some difference. So there's no rule for that. It's just the names just got their names, and now they have just put them all in some order. So this is the cerium, for example. And then there is also like here Mendelevium also. I always have to give that, Mendelevium. Okay. Now there are some of them, they have their Latin names. Latin names, like for example, potassium is K. Sodium is Na, right? Iron is Fe. Copper, copper is, I think copper is Cu. Think copper, I'm not sure. But so these names don't match. So this is potassium, this is sodium, this is iron, but their names don't match. So we use their Latin names. Now, some of them are the names like for example here, silver also. Silver, like gold, like mercury, you know, all these have. So, I mean, you can add on more, but that's what it is. Then some of the names, like another way of remembering the names is just look at the C's. Let's say, for example, start with C. So you will have carbon, you will have copper, you will have cobalt, you have like chromium, like you have cadmium, okay, like that. Let's say, for example, let's say P, like P. For P, there is phosphorus, there is lead. Lead is again that plumbus. So this is again the Latin name, lead. Then there is palladium, there is plutonium, right? And then there is polonium, okay? And then there is platinum, platinum, okay? So that way you can start with, like, say A. So A stands for, like, for example, actinium, okay? Like arsenic, okay? Like argon, okay? Like silver, like gold, like aluminum, like that. So this is another way you can memorize. Let's say B. B is like boron, like bismuth, like bromine, like barium. Okay. So this way. So, you know, you'll have to just get a hang of it, but start getting them, you know, just like professors have to remember the names of the students also, right? So you guys also have to remember, start memorizing it, okay? Now the last piece in this thing is the this is this is 8, this is 9. Okay. Here is the last piece is the formulas, chemical formulas. Okay, chemical formulas. Chemical formulas. Now, what we have written here on top and what I showed you in that periodic table, these are the symbols of the atoms. Atoms. All of them. In the periodic table, this is your periodic table. In this periodic table, these symbols, these are all atoms. Information about the atoms. Symbols, names, you know, and then we'll talk about more. But when we write the formula, what do? We put the arrangement of the atoms. So very definite arrangement of atoms. Definite arrangement of atoms. And what is that? For example, here, H2O and H2O2. These are different. H2O means 2 atoms of hydrogen mixed with 1 atom of oxygen to form water. And this is your life force. We can't live with water. We need it. Right? Agreed? But H2O2 is made up of 2 atoms of hydrogen and 2 atoms of hydrogen and 2 atoms of oxygen. And that is toxic. If you drink it, I mean, just use a little bit of it to gargle your mouth, right? When you go to dentist or something, but if you drink it, it's toxic, okay? Similarly, for example, you have another molecule, for example, NaCl. So like I said, it's important you start recognizing the symbols of these elements. Na means 1 atom of sodium and 1 atom of chlorine. Okay. For example, you have CO2. This means 1 atom of carbon and 2 atoms of oxygen. Okay. For example, you have CCl4. This means 1 atom of carbon and 4 atoms of chlorine. Okay, let's look at a few more. For example, you have a formula such as, let's see, from your book. Okay, let's do this. For example, you have a formula such as Mg brackets OH brackets closed whole twice. Now, what does this mean? This means that this 2 applies to oxygen and this 2 applies to hydrogen. Okay, so this means this molecule is made up of 1 atom of magnesium, 2 atoms of oxygen, and 2 atoms of hydrogen. Okay, let's look at another one. You have Al2. Al is aluminum, brackets SO4 whole thrice. What does this mean? This means that this 2 applies to aluminum. So there are 2 aluminums. This means 2 atoms of aluminum. Okay. Now, this 4 applies to oxygen. But keep this in mind, that is 3 applies to sulfur, S, and 3 also applies to oxygen. So there are 3 atoms of S, that is sulfur, and 4 times 3 equals 12 atoms of oxygen. Okay? So a total number of atoms are going to be what? 2 plus 3 plus 12. So what does this become? 12, 13, 14, 15, 16, 17. So a total of 17 atoms are making this molecule. So here, when we define a definite arrangement of atoms, that makes molecules. So what you see, the information here is molecules. So anytime you have like just these guys say single, single like this, all of them are just single. So that means they are atoms. So atoms are just by themselves, not combined. So just symbols, these are just symbols, right? Just like any language, you know, you English language, like A, there's a symbol for A, there's a symbol for B, symbol for C, symbol for D, like that. So same is the case here, symbols of elements. So these are just by themselves. They are made up of only one type of particles, and that particle is atoms. On the other hand, you have the arrangement, and in that arrangement leads to the formation of molecules. So molecules will be more than one type of atoms. And so you just add them up, that will tell you how many are there, you know, so this is how you go. Okay, guys, so right now, this is what I have. And I know I was supposed to start chapter 2. However, I mean, I already have those lectures up for you, so it's not like you don't have anything, but you guys can start it, but I'll do it tomorrow. I'm going to do it. It's not like I'm not. I will review and all that stuff. I'll do it. So let's just do this. I'm going to exit out of this and stop sharing. Okay, now let's just look at, give me 1 minute.